what I'd like to do is look at why at least a couple of these rules work. Why is it that you can take a power multiplied by a power, and if you add them together, you come up with the same number? It's very logical, actually, if you think about what these things mean. Let's look at the multiplication rule. The rule stated looks like this. It says that a to a power n multiplied by some number a to the power n equals a to the power m plus n. Here's an example of the rule. So if we had x to the second power multiplied by, very important, multiplied by x to the third power, you would get x to the 2 plus 3, and that would be equal to x to the fifth power. Here it is again, the rule. It can be read in English like this. Wow, huh? See how much information we pack into one simple rule? For any number or variable, let's call it a. See, we called it a by putting a there. Taken to some power, let's call that power m. Alright, there's our power m. If you multiply that same number or variable, notice we use an a again, representing that this number has to be the same number as that number, or the rule does not apply. That same number or variable, remember, we called it a by itself, and then taken to some other power, call it n. So we're having that same number taken to the n power, some other power. Then you can quickly find the result, or simplify this expression, just by adding the two powers together. That's all you have to do. Look at that number, add it to that number, and you'll get a result. That'll be your final answer. For example, x to the second power, x to the third power, we get x to the power 2 plus 3, and that equals 5. 2 plus 3 is 5. Boom! Trust me, the rule works, but let's explore why. What does x to the second power actually mean? If we dig apart what it actually means, it'll help us understand why the rule works. Well, x to the second power means x times x. And what does x to the third power mean? X to the third power means simply multiply x by itself 3 times. So it means x times x times x. And therefore, what does x to the second times x to the third power mean? So basically we're putting these two together. Here they are, multiplied by each other. I'll keep this little multiplication sign that came from this, and then we'll just pop things into place. There's x times x, or x squared. Here's x to the third power. I'll pop into place there. Wow, what do I get? I get x times x times x times x times x. X times itself 5 times. Altogether we have x times x times x times x times itself 5 times. That sounds like x to the fifth power to me. It's perfectly logical, makes absolutely perfect sense. We don't have to go through all this. Mathematicians got sick of going through all that all the time, so they invented the rule, because this always is the way it works out. Just add these two together and you'll get a proper answer. Clear? Of course it is. Let's move on to the next rule. We have a rule that if m is greater than n, then x to the m power over x to the n power is equal to x to the power m minus n. Why does this work? Well, first let me state it in English. For any number or variable, let's call it x. We called it x. Taken to some power, call it m. We called it m. If the number on top of the fraction, if the number is on the top of the fraction and it is also on the bottom of the fraction, but taken to a different power, or another power, call that power n, here's the number on the bottom of the fraction, here's its power, named it n, n as in Nancy, then you can simplify the expression or find a value by subtracting the bottom power from the top power. Notice I have a little typo here, sorry about that. That is value by, not but. Value it by subtracting the bottom power from the top power. Let's move along. Here's the rule. Here's an example of the rule in application. We have a variable, we have the same variable. We have a power 7 greater than a power 4. What we do is subtract 7 from 4, we get 3. We've seen this before. Now, why does it work? Once again, we need to see what each part really means. What does x to the 7th power mean? Well, bam, that's what it means. X times itself 7 times. How many x's do I have here? 7 times 7 times 7 times 7 times 7 times 7 times 7. That's 7 of them, all multiplied by each other. What does x to the 4th power mean? X times x times x times x. Does anybody remember that we can simplify a fraction if we have the same thing on the top and the bottom? Of course we can. We can cancel top with bottom. If the top and the bottom of a fraction are the same thing, they equal 1 and they can be canceled out. Boom. Notice I put the red slashes there. Death to all x's that are matched with other x's on the bottom. Be careful when you're simplifying though. If you're going to cancel something top and bottom, you need to make sure that they match exactly top and bottom. I can't cancel these x's here because there is no counterpart to them on the bottom. So I will be left with some x's. Guess what? That's exactly what the rule says I should be left with. I cancel 4 x's. All the x's on the bottom are gone because they got canceled out with 4 x's on the top. What is left over? I have x times x times x. That is sorry, I should have been kind of moving things along a little bit more. X to the 3rd power. X times x times x means x to the 3rd power. So this works, and we just saw why. Because when I write out x to the 7th power on the top of the fraction, and I write out x to the 4th power on the bottom of the fraction, I get a chance to cancel all of this stuff. But I don't have to go through all that work. This rule will save me all that work. If I apply it properly, all I have to do is subtract the top number from, well, subtract the bottom number from the top number. Or if the values were different, if that's a bigger number than that one, then I would subtract that one from this one, and I would put a 1 on the top, and I'd still have a fraction. Alright? Coming to the end of this thing here. So x to the 7th power over x to the 4th power is equal to x to the 3rd power. You could put this into a calculator and see. Choose any number for x, it'll still work. Is there an easier way to accomplish this? Sure. We apply the rule. Let's see. One more quick example, and then I think we'll be done here. Let's see one more quick example. We have a to the 8th power over a to the 2nd power. Remember, the name that I choose for the variable doesn't matter. A to the 8 minus 2. I take that 2, I subtract it from a. For a while, I put that over 1, but after I get my answer, 8 minus 2 equals 6, I can get rid of the 1 because anything over 1 is just that thing. So a to the 8th over a to the 2nd ultimately will be the same number as a to the 6th power. I cancel out 2 of these a's, and I get 6. Bye-bye. Work hard. Memorize these. Give you a chance to look at them. Know them. Live them. This PowerPoint, most of it was kindly donated from worldofteaching.com. I added my own stuff, and I'm also uploading it back to worldofteaching.com. These lessons are sponsored by Whalebone IR and Software, where the future is only 2 days away. You can buy our products safely and check out our feedback of 100% on eBay. Just search eBay for IR Pen. You can also visit our website at whaleboneir.com. TeacherTube.com. See ya.